Alright, so this is question number 5, also from the 2011 FRQ section of the exam. And to save us the time, instead of reading all this, it's just, all this is basically saying that there is this table, use it for the problem. So for part A, it says use data in the table to approximate Ben's acceleration at time t equals 5 seconds and indicate units of measure. So let's go over part A. So it said to use the data in the table to approximate Ben's acceleration at t equals 5. So acceleration at t equals 5 is approximately v of 10 minus v of 0, and this is a different quotient. So just pick numbers from the table. I picked 0 and 10. These first two right here, 0 and 10. And this is 10 minus 0, so like b minus a, and this is like finding the average rate of change, which can also be known as or referred to as acceleration. So we get 2.3 and 2 from the table. So like I said, we got 2.3, and 2.0. And then 2.3 minus 2 over 10, and then you just keep dividing till you get 0.03, and then notice units are meters per second squared. And that's it for part A. Now for part B, we are, for part B it says use the correct units, blah blah blah, interpret the meaning of the definite integral 60, 0 to 60 of Vt, absolute value of Vt dt. So what this means, what this whole thing means is it's the total distance traveled in meters from bounds being 0 and 60, because the integral of v of t is just f of t, which is the position, because v of t is like f prime of t. It's the derivative. So if you take the antiderivative, it would be position. You go all the way back to the original. And that's what we just answered. What does it mean? So that's the first part of the problem. That's what it means. For the second part of the problem, it's telling us to evaluate the equation that we were just dealing with using the left Riemann sum. And for the table, as you can see here, it's easier to draw those loops. So from 0 to 10 is going to be 10, 10 to 40 it's 30, from 40 to 60 is 20, and then you always use the left point and for Vt. So 10, like we said, from 0 to 10 it's 10, so 10 times 2 is the most left point, and then from 10 to 40 is 30, so 30 times 2.3, which is the left of that, and then from 40 to 60 is 20, so 20 times 2.5, which is the left point of that. And that's all it is. There's no really need to simplify this anymore, because this will save you time on the actual exam. That's it for part B. Moving on to part C. So part C is one of those, must there be a time when something is always true, or when something is true. And with practice, almost all the time, those problems are going to be related to MVT, mean value theorem, which means if f of x is defined and continuous on this interval, and it's differentiable at this point, AB, then there has to be a C which exists within that section. So B of t is differentiable, therefore MVT applies, and therefore on the interval 40 to 60, it guarantees that v of t which really is just b prime of t, for some value for b of 60 and b minus 40 over 60 minus 40, which is again is like an average, or an average that we will find within those bounds, that's guaranteed to be there. So b of 60 and b of 40 minus 60 minus 40 is our equation, and from the table we get 49 minus 9 over 20, because b of 60, 49, and 40 is 9 right there, and then 60 minus 40 are the bounds, so 20, and that equals 2 meters per second. And that means for at 2 meters per second, for some value of t between 40 and 60, that this interval, there has to be a value. So therefore, yes, there must be a time when something is true, because of the MVT and because BT is differentiable, which means MVT applies. And for part D. Alright, part D is just a related rates problem. It gives us LT squared equals 12 squared plus BT squared. And it's a rate of change at t equals 40, and that's what is given from the problem itself. So first thing you need to do for related rates is take the derivative of this, the whole thing. So it'll be 2LT times L prime of t, and I did this using the chain rule, and same thing for this side. So the integral of 12 squared is just 0 because it's all constant, and then same thing, chain rule, b of t times b prime t. And then just to simplify this up a bit, just move this over to get the L prime t by itself. So this is just rearranging, nothing too complicated. Let's see. So at t equals 40, that's what we need. So at t equals 40, L of 40 or L of t squared is going to be 12 squared plus 9 squared, and these values I have from the table, because at 40, right here, you have the 9, and that's where the 9 squared comes from, and the 12 squared is from the original right here, 12 squared and 9 squared, and this is just a squared up triangle. 12 squared plus 9 squared equals 15 squared. So this is the same thing as a this is the same thing as a Pythag right triangle that works with Pythagorean theorem. So it would be 15. So this would equal 15 squared. The 15 squared and squared just cancel off, and L of 40 equals 15. So L prime of 40 equals 9, and again the 9. So L prime of 40, same thing as BT, and I get the 9 from, that's where I get the 9 from, at 40. So we have 9 times 2.5, because with the 40 and the 9, V of t is 2.5. And once you have that, you just divide by 15, which we just found, which is L of 40, and that's just miles per second. And then you can go ahead and simplify this further on, but there is really no need for this. And that's all for number 5.